So this is the second part of 9.2, but everything I'm going to talk about in terms of the power of the test stands true for significant tests with proportions as well as significance tests with means, which is this 9.3. So we're specifically going to be looking at these things that have to do with the power of the test, what factors affect it, and what it means. So first we want to talk about type 1 errors. And the significance level of your test, your alpha, is this part of the distribution of the null that by chance is included in that distribution of a 0.08 in this case, which is the null hypothesis. All of the different results that can occur with a 0.08 proportion. And so the alpha, you could, before you even ran a test, you could run the z on a 95%, which would be right there, and then you could use the 0.08 and find out that any p-hat or any statistic that is greater than 0.0999 we would consider statistically significant. Now that means that by chance it's possible that that value would be in a naturally occurring distribution of 0.08. So when we talk about error, we're not talking about a calculation mistake or a mistake in the actual creation of the study, but the fact that what happened in the statistic and what could happen just by chance fall in that same area. So that's why an alpha is exactly the value of a type 1 error, because it could happen by chance or it could happen with a statistic and they overlap with one another. In the previous slide, a calculation was made of a cut point of 0.0999. Anything above that was going to be considered statistically significant. Now this distribution looks different because this distribution has to do with the assumption that the alternative is true. And so we have a distribution not of 0.08, but of 0.11. So this distribution of 0.11, this gray part is called the power of the test. And this probability is 75.17%. So this particular test has a 75% probability of coming to the right conclusion when that alternative is true. In this case, we are rejecting the null. But a type 2 error would be that we'd fail to reject the null when the null is false and the alternative is true. So a significant test makes a type 2 error when it fails to reject a null hypothesis that really is false. So if our null was 0.08 and that was incorrect, the type 2 would fail to reject that when it really needed to be. We talk about, there are many values of parameter that can make the alternative hypothesis true. So in this particular case, we're paying attention to one alternative possible parameter. And that number normally comes from a statistic that comes from a well-designed experiment, an observational study, or in the case of the potato chip problem we're about to look at, it comes from quality assurance in a manufacturing situation. The probability of making a type 2 error depends on several factors, including this actual value. 0.08 and 0.11 are not that far apart, but they're not super close to one another, and that's called the effect value, how far apart they are. That does affect the type 2 error, and it does affect the power. A high probability of type 2 error for a specific alternative parameter value means that the test is not sensitive enough to actually detect that alternative. And a high type 2 means a low power. A low power means a high type 2. So in this particular case, the potato chip producer wants to find out if they're excuse me. Here we are with that same information. Okay, so now we know how to run a one sample z-test on population proportions, what we need to check ahead of time, what happens when our p-value is below or above our alpha level, even what we're looking for when we lower our alpha level or increase our alpha level. The second part has to do with the power of the test. What probability do we have to properly reject the null when the alternative value is true? So remember that the type 1 error is always going to come from a distribution of the null value, and a type 2 error is always going to look at the distribution of the alternative value, the alternative parameter value that they're trying to see if that's true.